Hello, good evening all. So today I'm going to record the first hydraulic engineering lecture. I'm Om Prakash Maurya from IT Guwahati. So I am the TA of your hydraulic engineering PMRF NPTEL I'm doing here. So I'll solve here the lot of questions, the previous year hydraulic engineering assignments. So I'll solve the 2025 question and 2024 and 2023 question here. Along with if we have the time, then I take the another questions also. So now let us discuss the first question. The first question is for an incompressible fluid, let me just take the pen. Does density vary with temperature and pressure? The first question. Option A, it varies for all temperature and pressure range. It remain constant. It varies only for lower values of temperature and pressure. It varies only for higher values of temperature and pressure. So before discussing the question one, so actually the today class was scheduled from 5 to 7, but due to the network issue here in IIT Guwahati, so I was not able to take the class at on the time 5 to 7. So I'm recording the video right now because during the recording there is no need of the network. Once the network will I'll receive, then I'll upload on the YouTube and also link I'll provide it in the Excel sheet. So hopefully you will understand the problems here. So now let us discuss the question number first. For an incompressible fluid, does density varies with? Here, the density varies with temperature and pressure. You have the three term temperature and the pressure. If the density is increased, what will happen with this? Or you can say if the temperature or pressure will change, what will happen with the density? So it varies means here the densities varies for all temperature and pressure range. It remain constant means density remain constant whatever you have the temperature. For example, this is your density column, this is your temperature column, this is your pressure column. So let us density X, temperature is Y and here Z. If the temperature is Y plus and pressure is Z negative, means you are reducing something. Here you are increasing, here you are reducing. Then what will happen with the pressure? Whether it will be the X. If it is X, then option B correct. If it is change with this, with the both range, then option A correct. Option C, what is telling? It varies only for lower values of temperature and pressure. It varies only for higher value of the temperature and pressure. So you here you have the four option. So which option will be correct? Just you can think, you can pause the video, you can think, then try to reply. So here I'm going to show you the answer first. Okay, so it remains constant. Yes. Detailed solution for an incompressible fluid. Remember please here, for an incompressible fluid, the change in density is negligible. Thus, it does not change with temperature and the pressure. Incompressible fluid we are talking about. Incompressible fluid means your density does not change. Okay, now for your compressible fluid, remember please, for compressible fluid, you can say the gas. Here you can say the water, I'll say you. Just for example, you can say, or air here you can also write. So for compressible fluid, your density change with temperature and the pressure. Now the question number two. The pressure at any given point of a non-moving fluid is called. The pressure at any given point of a non-moving fluid is called the gauge pressure. Remember, please, the pressure at any point of a non-moving fluid means you have some container, and within the container, this is not moving fluid. The wall, the your fluid is surrounded by wall, not moving, is called the gauge pressure, atmospheric pressure, differential pressure, or hydrostatic pressure. Atmospheric, differential, or the hydrostatic. The pressure at a given, the pressure at any given point, let us suppose you are going to measure here P at distance H from the top. So non-moving fluid, non-moving fluid here. So what will be the your pressure at P? So it is rho density of your fluid G H. So this will be the your. So now you can guess whether it will be the gauge pressure, atmospheric pressure, differential pressure, or the hydrostatic pressure. Just to guess. You can pause the video, you can understand by yourself whatever sir has taught already in your B1 classes. So here your final answer will be the hydrostatic pressure. Remember please. The final answer will be the hydrostatic pressure. Very, very important question. So detailed solution, let us read. The hydrostatic pressure varies with the increase in depth. Here you can see that your pressure at point P is directly proportional to, because for the fluid, for your incompressible fluid, this will be the constant. Rho will be the constant, G will be the constant, H is varying from top to bottom. So it is directly proportional to H for what? For incompressible fluid. Remember please, for incompressible fluid. And your pressure at point P, any point P, is directly proportional to your rho plus H for compressible. So hopefully you are understanding. Okay, so detailed solution, hydrostatic pressure varies with the increase in depth. Okay, the hydrostatic pressure is measured from the surface of fluid because of the increasing weight of the fluid. What is the meaning? I'll just tell you. Let us assume here you have a tank, and in the tank you have water. Some. So why we measure from the top? Because as we will come down, let us suppose if you are measuring here. So the pressure will be how much here? Whatever you have the water above it. As we will move down, the whole water will consider for the pressure. As we will move again down, the above water will be responsible for pressure here. So that's why you need to measure. The fluid exert a downward force from the surface of water, thus making it a non-moving fluid. Okay, now let us move on the next question. Question number 3. Very important. Okay. So question 3 is, which of the following is used to measure hydrostatic pressure? All questions are linked, please. Just to if you will think, so all questions are linked one by one. So whether you will use the Venturi meter, manometer, orifice meter, or the none of the above. So these are the two devices for measuring the discharge. Manometer is used for the pressure measurement. So you can say here, your pressure measurement you will use manometer. Option B is correct. The manometer is a pressure measuring device that is based on the principle of balancing the column of liquid. What is the principle of manometer? Let me just write here. Manometer principle is the balancing the column of liquid whose pressure is to be found by the same or another column of liquid. So hope you understand, because once we will solve the problem on manometer, you will definitely understand this. Okay, next question, question number 4, very important. A fluid which has shear stress is proportional to the rate of shear strain. Very important. Shear stress tau is proportional to shear strain. I'll write with the phi. Okay. Shear strain is called real fluid, ideal fluid, ideal plastic fluid, ideal fluid, or non-Newtonian fluid. Remember, shear stress is directly proportional to d phi by, here I write d phi by dt or du by dy. Which option will be the correct? Means for such type of relation, which fluid follow? Ideal, ideal plastic, real, non-Newtonian. So it is real fluid. Remember, please. Option A is correct for this. Question number 4. So what is details use? So here you have two definitions, ideal fluid, real fluid. Very important. So I'll just go one by one. Okay. So ideal fluid. The fluid which do not have viscosity and are incompressible are termed as an ideal fluid, not have viscosity. Dynamic viscosity will be the zero for ideal fluid. Such fluid do not offer shear resistance, that is, no resistance is encountered as the fluid moves. There is no resistance in the ideal fluid, remember please. Now, real fluid, fluids which does possess viscosity are termed as real fluid. Means your real fluid have some viscosity, does not equal to zero. These fluid always offer shear resistance. Certain amount of resistance is always offered by these fluid as they move. Newtonian fluid, the fluid for which the shear stress is not linearly related to the shear strain is called non-Newtonian fluids. Linearly not related. Remember this. Means your diagram of the non-Newtonian fluid not be like that. Not be like that. Remember, because it's linearly varying. In Newtonian fluid, the viscosity is depend on shear rate. In non-Newtonian fluid, The viscosities depend on shear rate. So remember please here. Very, very important. Okay. Question number 5. Milk, blood, and clay are example of fluid. Ideal, pseudoplastic, perfect, Newtonian. So milk, blood, and clay are the example of your pseudoplastic. Remember, please. So how your shear stress behave and how related with your shear strain here you can see. Option B is correct. Pseudoplastic. Detailed solution. The relation between shear stress and rate of deformation, that is velocity gradient, can be represented by this formula. Here you can see tau is equal to m del u by del y power n. Here n is your flow behavior index. This is your flow behavior index, and m is your consistency index. Remember please. And for Newtonian fluid, the fluid for which shear stress tau is directly proportional to deformation rate or velocity gradient are Newtonian fluids. M is equal to mu here for Newtonian fluid. M is equal to mu and N is equal to, here if I write mu del u by del y power n, this is 1, so you will get here del u by del y. So this is the relation of your Newtonian fluid. How Newtonian fluid related with your shear stress, shear strain, and dynamic viscosity. So here the example you can see. Very, very, very important. The plastic fluid, idle fluid, shear stress, and this is your velocity gradient. So you can see very clearly how the thixotropic, Bingham plastic, rheopactic, pseudoplastic, Newtonian, dilatant fluid behaving. So Newtonian fluid here you can say it is behave linearly. Here your Bingham plastic fluid also behave linearly, but with some C value. And C value why I am telling here, you can correlate with y is equal to mx plus c. So for this you need to draw graph like this will be your C value. From here your we have linearly. So this is Bingham plastic we can correlate. Now y is equal to mx. M is here, M is slope of this line. So equation for this graph for this equation will be from origin. Remember this. This is your thixotropic, this is your rheopactic, and this is your dilated, this pseudoplastic, dilated the greater than 1. Means your tau is equal to mu del u by del y, and here n is greater than 1. The n value is greater than 1 for dilated. Greater than 1 means maybe the 1.5 to whatever, but greater than 1. Remember, please. For pseudoplastic, less than 1. Tau is equal to mu del u by del y, n less than 1 means it may be 0.8, it may be 0.9, it may be 0.5. So like that, remember. So this is about, this figure you can please remember. Ideal fluid here you can see. There is no, here you can see shear stress. For ideal fluid, as we have discussed already, your dynamic viscosity will be the zero. If because your shear stress is related to dynamic viscosity also, some another term. But if this is zero, then tau is equal to zero. So that's why here you can see for the ideal fluid, the plot is associated with your velocity gradient, or you can say the x-axis. For the plastic fluid, what we will do? For plastic fluid, velocity gradient zero, not zero, constant. If this will be the zero, then what will happen? For plastic fluid, not. I think if this is your graph for the plastic fluid, so shear strain will be the zero because this line is start from zero. So you can say it's zero consistently. That is the constant value. You can say the zero value is the constant. So hope you understand. For your ideal fluid, your shear stress will be the zero. For plastic fluid, your velocity gradient will be the zero. Okay, now here you can say very for non-Newtonian fluid, little bit explanation about the question. Very, very important. So fluid for which the shear stress tau is not directly proportional to the deformation rate or velocity gradient are non-Newtonian fluid. The fluids for which the shear stress tau is not directly proportional to deformation rate or velocity gradient are non-Newtonian fluids. Okay, means directly proportional to no. Means it may be n minus 1. Okay, Here you can say very this term you can write. Okay, what this line try to explain here? Let me just explain you. You know, for the Newtonian fluid, the relation is mu del u by del y. You can write these things very easily. Mu del u by del y del u by del y n minus 1 means for Newtonian fluid, non-Newtonian fluid, tau is equal to, del u by del y to the power n. So if I'll write here, because this value is having the power 1, so minus 1 plus 1 will be the cancel out, you will remain again mu del u by del y. So here you can say one thing, this value is m. So m and this combinedly you can say m del u by del y power n minus 1 is your mu, and this is known as apparent viscosity. As per the value of n, the non-Newtonian fluid is various type, which can be shown in the here in the above graph you have already seen. The pseudoplastic, the fine particle suspension, the fine particle suspension, gelatin, clay, blood, milk, paper pulp, and the polymeric solutions such as rubber, paint. These are your the pseudoplastic example. So remember, please, you can expect the question from here in your final NPTEL exam, and you can find many. I think you have seen the many questions designed from this section for the one day exam, means one day competitive exam. So these are the section is very important, especially the graph. Okay, next question, question number 6. The depth of center of pressure. The depth of center of pressure for a rectangular lamina of height h and width b immersed vertically in water with its longest edge vertical and top edge touching the water surfaces. So let us first understand the one very technical term, lamina. What is lamina? So here you can see you have one rectangular lamina with height h, width b, but it's not given about the thickness value. Where is the thickness? Means the thickness of this rectangular thing is very less compared to your height and width. That's why you can consider the thickness is very less, so you can consider the rectangular thing is lamina. Let us let me just give you example. So if you have some rectangular thing like that, okay, so this is your rectangular thing. So now what you will do, this is your rectangular thing. So the thickness is very, very small. These are the thickness. This is the thickness here you can assume. So hopefully graph is not very clear to you, but you can understand. The thickness is very, very less. Not, this is your width, I think. So, okay, hope you understand what I'm trying to tell you. Let me just draw the height. This is your height, h, and this is your width, height h, width b, and thickness is this, very, very small, very, very small thickness. This is your thickness, very, very less. So, hope you understand what is thickness I'm telling. So, this first type of body is known as your lamina, means your h and b is very, very much than t. Such type of body immersed vertically in the water. Vertically immersed in the water with its longest is vertical and top is touching to the water surface. The top edge is touching to the water surface means this is your water surface and longest is vertical. The longest edge is vertical here you can see. So what will be the center of pressure? So center of gravity of this h by 2 or centroid you can say h by 2, centroid is h by 2, and you have to calculate the center of pressure. So center of pressure little bit lower here. This is your centroid and this is your center of pressure. So this value will be the greater than center of pressure will be the greater than h by 2. But what will be the exact value? So you can think, you can pause video and you can try to solve. First, you can try to solve before see the solution. Remember, please. Such type of question you can expect in your gate examination or engineering services examination for 1 marks, 2 marks. Okay, so I'll show you the solution. So it will be the 2h by 3. So what will be the solution? So this is here representing by the HP. So this will be the HP and this will be the H bar. So H bar is H by 2. What is IG? IG is nothing but this is the your G value. Here you can see C and G both you can write. So IG is moment of inertia about the centroid. So it is BH cube by 12 and what is A? A is area. This is your moment of inertia about centroid or you can say this G central axis here you can say and area B into H because it is rectangular. So you can very easily calculate. Your HP is IG AH bar plus H bar. BH cube by 12. BH into H bar is H by 2. So BH cube by 12 and BH square by 2. So BB will be the cancel out, HH will be the cancel out. So here only H1H will be the remain here. So 2H and another here is H by 2 is remaining. So here 2H by 12 plus H by 2. So here the 12 2H. I think we are doing somewhere mistake. Okay. Okay, not. So 2H plus 6H means 8H by 12. 4 2 is 8, 4 3 is 12. So 2H by 3. So 2H by 3 will be the final answer. So option C will be the correct for this. Option C will be the correct for question number 6. Very important. This formula is very, very important. You can apply this formula for your rectangle or triangle also. How? I'll just give you one question for next class I'll discuss. So the question is the similar question. You have one the rectangular triangular lamina. I'll give you two questions. One is like that, the completely in water, the depth is h. Another lamina is like that, width b and depth h. Now I need for this your center of gravity and for both and your center of pressure for first case, for second case, both. So I want from your side in the next class, I'll ask to you and we'll solve. If you will not able to solve, I'll just show you how you will solve. Okay. Question number 7. The fluid occupies 4 meter cube. For the fluid occupies 4 meter cube. Calculate the specific gravity if the fluid mass is 12. Fluid mass is 12 kg. So here you need to calculate the specific gravity. Remember please. Specific gravity you need to calculate. If fluid occupies 4 meter cube, so what will be the specific gravity? Means the density is, here question is, if something you have the the 12 kg and for putting this 12 kg you need 4 meter cube. So what will be the density? Density is mass by volume. So mass will be your 12 divided by volume. Volume is 4. So this will be the 3. Density is 3 meter cube per or not kg per meter cube. Now what will be the specific gravity? Specific gravity of your the density of your anything, density of your fluid divided by not anything, density of the fluid divided by density of standard fluid. So for a standard, we'll consider water. So water density is 1000. So 3 divided by 1000. So this will be your 0.003. So this is your final answer for question number 7. Specific gravity is dimensionless, no unit, because you are dividing here density by density. Remember. Next question. So detailed solution here it is given. The density is mass by volume of the fluid. So 3, and hence the specific gravity is, you can see, the density of fluid divided by density of water, that is 3 by 1000, 0.003. Next question. Okay, next question is dimension of the coefficient of dynamic viscosity. In notation here you need to follow FLT. So F is nothing but you're representing the force unit, means Newton. For Newton you can write directly F. No need to go with the mass, that is mass into acceleration. When you will convert this force in unit, you need to write the mass into acceleration. Mass is kg and acceleration is your meter per second square. So mlt square, mlt minus 2 for the force. But here you need to write directly for Newton F. So what is the dynamic viscosity unit? How you will calculate? Let me just show you. Tau is equal to mu del u by del y. So tau is what? Force by area. So Newton divided by meter square, mu velocity meter per second, and this your length, that is y, depth. So this is also meter. So meter will be cancelled out. So your mu unit will be the Newton second per meter square. So for Newton you will write F. For T you will S, for you will write T. For M square you will write L. So M L square T minus 1. Not M minus 2. T will be the positive. So this will be the your, not M. Here will be the F. So F L minus 2 T. So option A will be the correct. So hope you understand what I am trying to say. So if you want to write for in terms of M, so for at the place of F you will write M L T minus 2 L square T. This is your minus. So M L minus 1 and your T minus 1. So you can calculate in terms of your mass length time. Here is the in terms of force length time. The pressure at any point in a fluid at rest has the same magnitude in all directions. This fact is known as the pressure at any point in a fluid at rest at the same time in all directions. uh, has the same magnitude in all direction, not at the same time, has the same magnitude in the all direction. This fact is known as your Pascal law, Newton's law, the pressure law, and the Bernoulli's law. So definitely this is your Pascal law, meaning you have one fluid system in the rest. So I'll take the fluid in the container again. Already we have taken once. So this is your fluid. Now you want to calculate here the pressure at the particular point. So the pressure at any point in a fluid at rest, this is your rest, that is velocity will be the zero, has the same magnitude, means from this direction, from this direction, from you can see the within the screen, outside, and the from outside of the screen, everywhere. The magnitude is same. Remember, at the same level, please remember. Not like that. If you are considering the, let me just give you one example so you will understand very easily. So in all directions, so this law is known as the Pascal. What I'm trying to tell you, you have one the instrument like that. Here you have some plunger, and here you have above it one plate, and above the plate you are putting some car for lifting. You have put it car for lifting, and this is your load. Load by a man, let us say, is a man. The man is standing on the plunger. Just think on that. Is it possible to lift the car with the weight of the man? So such type of question you can solve very easily with the Pascal law. Such type of question, such type of instrument based on your Pascal law. So whatever you will apply the pressure here, the throughout the your this fluid is same. Remember the condition here, the fluid should be the same. If the pressure here is 20, so at the same place here the pressure will be the 20. If the pressure is 200, here pressure will be the 200 at the same level in the fluid. So what is force? Pressure is force by area. So force will be the pressure into area. So let us suppose the force, we can say the weight also. So how much weight here? So if this area is, let us assume this area is 100 meter square or 10 mm is 100 mm square, and this is your 10 mm square. So the weight here, weight at point 1 is, or force at point 1 is pressure 200 into area is 100 mm square. So here is force is, okay, 200 and 100. So 2 into 10 to the power 4. And this is your Newton per mm square. Newton per mm square. So the force will be here, or weight will be there here. 2 into 10 to the power 4 means Newton. Here you can write 20,000 Newton. Here, how much? If you are applying the pressure to 100, so how much force here applied, or how much force is applying by the fluid? If here the pressure, it is already, the using the Pascal law, 200. So what will be the force? Here the force will be force is equal to pressure 200 divided by 5 or 10 here. So 10. So this will be the your 2000 Newton. Now, whether this instrument is efficient, you are applying the load here 2000 Newton, and you are able to lift only the 20,000 Newton, and you are able to lift only the 2,000 Newton. So whether this instrument is your efficient, not. But let us change the situation. What I'm trying to say, you man standing here, that is with the 2000 force you are applying this fluid, and you are lifting here how much? 20,000. Lifting the thing of 20,000 kg. Only you are applying the 2000. With applying the 2000 load, you are lifting 20,000. Remember, please, 10 times more. So you can design such type of instrument based on your Pascal law. So very, very important. So now let us move on the final question for this week of first, that is your NPTEL 2025 questions, hydraulic engineering. Then after I'll solve, I think, next for your 2023, and also I have for from 2024. So let us finish for 2025 question. Sorry. Okay, so here detailed solution is given. The Pascal's law state that the pressure exerted anywhere in a confined incompressible fluid is transmitted equally in all directions throughout the fluid. This principle applies to the fluid at rest. Remember, please, apply property fluid at rest and is fundamental in understanding the fluid mechanics and hydraulics. Remember, please. Now, the question number 10. Which of the following is an example of phenomenon of surface tension? Which of the following is an example of phenomenon of surface tension? Raindrop, rise of sap in the tree, break up of liquid jet, all of the above. Which of the following is an example of the phenomenon of the surface tension? Remember, please, you have to understand first what is surface tension, how it is happen on the surface. So I'll take the example of water. in a container again. Again, I'll take the water in the container. So if you will see very clearly, surface, the water at the surface is like that, not completely straight, not completely straight. It is like like that, not from here, very small, like that, not straight. So what? This is like that. Means the molecule within this water is try to like that. Is try to here you can say try to attract. So on the surface, one tension is created. Here you can say on the surface, one tension is created, and this tension is known as your surface tension. Even raindrop. Let us assume the raindrop. What is raindrop? Initially, it is what? Water. Water, if you will put the water on the surface, it will be like that. Flow will like that. But how raindrop is circle type, sphere type? Because of surface tension. Why? The surface, the outer surface of the raindrop is on tension completely. So that's why it is sphere type. Remember, the rise of sap in a tree, breakup of liquid jet, all of the above. So remember, please, the solution will be the all of the above for this question. So detailed solution here, the raindrop, rise of sap in a tree, the break of the fluid jet are the example of the surface tension phenomenon. So this was your Jan 2025. So I'll write here my email ID. You can write your question if you have in between. Not 1996 iitz dot ac dot in. Everything in small. So this is my email ID of IIT Guwahati. So you can write. Or I'll take some interactive session tomorrow also. I can take. You can come 5 to, you can come from 5 to onwards, 5 onwards, 5 p.m. onwards. So I'll take one interactive session because due to the some network issue, I was not able to take the interactive session. That's why I'm recording and I upload. You can go one by one, my video, like whatever I'm solving here. But for interactive session, I'll sit again on tomorrow. See, I'll sit tomorrow from 5 p.m. onwards. So if you have any doubt, you can ask me, or we'll discuss about how we'll proceed with this course, uh, how I'll solve the questions, and what you need to ask, what type of question expected to come your final exam. So we'll discuss. So I'll wait. I'll wait from 5 p.m. onwards. If anyone will join, then we can discuss. No issue. Now let us move on the next assignment. Okay. So now I'll take some 5 minute break for I'll go for the water. So then after 5 minutes, I'll start. Okay, so now let us solve the question number one. A fluid occupies 12 meter cube. Calculate the specific volume in kg per meter cube if the fluid mass is 8 kg. The similar question we have solved, but in the previous question was the specific gravity we need to calculate. But here we need to calculate the specific volume. So how you will calculate? So let us discuss. So specific volume here, the unit is given. This is very, very important. So from the unit you can calculate. The specific volume is nothing but your kg means 8 divided by 12. So definitely the option A will be the correct because nominator is less than denominator, so it will be less than 1. Only one option you can see here. Option A. Oh, wow, it is in kg per meter cube. Okay. So here, how is it possible? I think here is a mistake in the question. Here you can see the volume in meter cube and the mass in kg. So this unit will be the here if you are solving with this, so meter cube by kg, meter cube by kg should be there, not the kg per meter cube. So here I think in the formulation of the question, the mistake is meter cube per kg. Yes, here you can see in the next there is in the previous year the question was same but with the different data. So calculate the specific volume. So here meter cube per kg is given. So similarly here also meter cube per kg, not the meter cube. That's why based on this unit I was solving. So that based on that we will go with the option A. But for mm, meter cube per kg, then you need to uh, divide by 12 by 8. So 1.5 kg per meter cube. So this will be your final answer. So specific volume is your mass, that is volume per unit kg. So now let us move on the next question. Very, very important. An ideal fluid is, as we have solved already. So an ideal fluid is non-viscous, incompressible, viscous, incompressible, viscous and compressible, non-viscous, compressible. Your ideal fluid is non-viscous, you know already. Mu will be the 0, but whether it is incompressible or the compressible. That is, rho does not equal to zero. That is, rho here not equal. Rho does not equal to constant or rho is constant with temperature and the pressure as we have seen. So it is your non-viscous and incompressible. Remember, detailed solution here written very well. So I'll just read and explain for you the detailed solution. And ideal fluid is the kind of fluid that has no viscosity, and incompressible. This simply means that an ideal fluid is a non-viscous liquid that contains zero tangible force among the layer of liquid in relative motion. What is this line is telling? I'll just tell you. The line is telling you, let us assume the water is flowing over a floor. So, or you can say the water is flowing in a channel, rectangular channel. So this is a depth, and this is your the bed, and the channel is like that. The water is flowing. The water is flowing here. The water is entering here and exiting. The rectangular channel, water is flowing. Okay. So now the water will flow in the layer wise. And this is the layer, the first layer. If the flow is laminar, I'll just, because if you are trying to understand some basic things, so we have to assume the many things. Water is flowing in the layer form. So what this layer does, now I'll show you the side view. So a layer is like that. Water is flowing in the layer, in the layer. So if in between the layer is, there is no friction or no viscosity, you can say, so there is no resistance. So whatever will be the velocity here, the similar velocity will be the here. Means throughout the constant velocity. From here to here is the constant velocity. But if the fluid have resistance, then the bed here will be the zero. Then this value try to resist this layer, and this layer try to resist this layer. This layer is try to resist this layer. As you will move from your bottom, so what will happen? The resistance, the effect of this bottom will be reduces. So here you will get only, here is the zero, velocity is zero, and after that they increasing. After certain time, the effect of this wall will be negligible, and your the velocity profile will be the constant. So this was is telling here. This simply means that ideal fluid has no non-viscous liquid that contains zero tangible force among the layer. In between the layer, there is no tangible force, no tangential force. The density of the liquid remain the same even after the application of the pressure. To understand is better, let's look at some properties of an ideal fluid. Okay, here is not explained. Only statement is written. So now let us move on the next question. A small shear force is applied on an element and then removed. Okay. A small shear force is applied on an element and then removed. If the element cannot regain its original position, what kind of element can it be? Whether it will be the solid, liquid, fluid, or gas. So you can also go with the liquid, you can also go with the fluid, you will also go with the gas. But you have only the option one, so the fluid will be your best choice. The option C will be the best choice. If you have the multiple options, you can go with the all three: liquid, fluid, gas. By the way, for your kind for information, the fluid is the combination of these two: liquid plus gas. This combinedly, these two things, liquid and gas, we we tell fluid. If someone is telling you fluid, you just try to understand he's not telling about the liquid or not only telling about the gas. He's telling about the combinedly both. Okay. So now let us move on the next question. So here you can say the fluid is the liquids and gases cannot resist even a small shear force and get permanently deformed. Hence, the element must be the fluid element. Question number 4. A hydraulic press has a ram of 30 centimeter. The hydraulic press has a ram of 30 centimeter diameter and a plunger 3 centimeter diameter. It is used for lifting the weight of 60 kilonewton. Whatever I was telling in the previously, for example, when I was discussing the Pascal law, you can remember that thing. The similar question is here. Find the force in kilonewton required at the plunger. Up to 3 decimal place here. Right. Find the force required at the plunger. So you have the hydraulic press, has the ram 30 centimeter. One you have the 30 centimeter, okay. Another is 3 centimeter. Ram 30, plunger 3. Okay. So this is your 3 centimeter diameter and this is your 30 centimeter. So it is used to lift a weight 60 kilonewton. Find the force required at the plunger. So this side you need to required force F and this side you need to lift 60 kilonewton. So you know one thing, the pressure here and the pressure here will be the equal. The PA, this is A and this is B. PA and PB will be the equal, means force at A divided by area at A equal to force at B divided by area at B. Force is nothing but 60, already given, kilonewton. Okay, fine. You need to calculate the answer in kilonewton, so I'll keep it all in the kilonewton. And the centimeter, 30. This is the diameter, so pi by 4 into 30 square. I'll keep it in again in centimeter. And the force at B is you need to calculate. And area in centimeter, pi by 4, I'll keep again in the centimeter, 3 square. So pi will be the cancel out. And here 3 3s are 9. Here also, so 100. So FB will be the 0.060 kilonewton. Means 60 Newton you require. Means 10 times less. So here one thing you can say very clearly. 10 times less means what? Here you can say the 10 times greater diameter also. Means your plunger diameter at plunger is 3 centimeter. Diameter at ram is 30 centimeter. Means the ratio of ram divided by dp is 10 is equal to the ratio of fa divided by fb. So fa is nothing but your 60. If we'll divide with the 10, fb, so 0.6. Just I'm trying to give you some very close relationship. 30 and this is the 10 times less. No, it is 100 times. Remember, please. That is 10 square. Means whatever you will get the ratio here, if you are getting the ratio 10, then is this ratio square, this ratio square will be the, is this much. Means the 10 square, so again 10 and FB. So FB is equal to 0.060. Means here you can say very easily the your RAM and DP ratio is square is your FA divided by, or FR I'll write here again, FR divided by FB, that is plunger. FP. So hope you understand. So ratio relationship here, maintaining. This your such type of question. Remember, please. So in short, you can also tell very easily. Okay, now let us move on the next question. Okay, somewhere I am doing mistake. You can just, oh no, 0.6, not 100. Okay, here was the calculation mistake. If it is 60 by 100, so it is 0.60, not 0.006. So option A is correct here. Option A is correct, but here I think again, let us come again here the relationship. This is not relationship. The square is not. Remember, please. So square is not. Sorry for that. So your F A divided by FB, that is F at your RAM divided by F at plunger, is directly your D of RAM divided by D of plunger. So D of RAM and plunger will be the D of RAM is 30 and plunger is 3, so it is 10. So FR is 60 divided by F plunger. So F plunger will be, no, this will maintain the square. Okay, sorry. This will maintain the square. Remember, please. This will maintain the square. Okay, that's why I was checking. So this will maintain the square. So here is square. So 10 square. So FB is equal to 60 by 10. So 10 squared is 100. So 0.6. So this will maintain the square. No issue. Okay, here the only the calculation was mistake. So dr by dp square is equal to fr divided by fp. The simple relation. Okay. So now let us move next question. Question number 5. So the equivalent head of mercury corresponding to 4 kilopascal is, take specific gravity as a mercury 13.6. So you have the 4 kilopascal. So the equivalent head means what? Equivalent pressure. Head means here pressure, rho g h. So each h here is head. So rho is 13.6 is a specific gravity 100 multiplied with, then this is your rho, and g is, I'll take here the 10, and head you need to calculate. So kilopascal. So I'll just convert in the pascal. So this thousand will be the cancel out. So 4 divided by 136 H. Again, and the answer in centimeters. So again, I'll write here the 100. So you whatever you will get in the centimeter. H centimeter. So it is how much? It is possible to 3 times? Yes. Within 3 times, we will completely. That is very near to 3. So option A will be the correct for this. Question number 5. Okay, now let us move on to question number 6. The specific weight of seawater is more than that of the pure water because its content. dissolved air, dissolved salt, suspended matter, all of the above. The specific weight of the seawater is more than that of the pure water because it contains dissolved air, dissolved salt, suspended matter, all of the above. So it is all of the above. The seawater contains air, salt, matter. That's why it is more. Okay, now let us move on the next question number 7. The which of the following is the dimension of the mass density, mass by volume, kg per meter cube. So if you want to write in mLT minus 2, how you will write? Because here is no second term, so T will be the 0. So ml minus 3 T0. This will be the final answer. ml minus 3 T will be the 0 minus 3. Option A, here your option A is correct. M1, here you can write very easily M1 minus 3, L minus 3 and T0. A option will be the correct. Next question. Surface tension at in a plane of interface normal to any line in the surface is also known as capillarity, is a function of curvature of the interface, decreases with the fall in temperature. Means surface tension decreases with when the temperature is decreases. Option D. It in a plane of the interface normal to any line of the surface. So option A is correct. It in the plane of interface normal to any line of the surface. Remember please. How? The detailed solution here it is given. I'll just read for you. The surface tension is a force per unit length. The surface tension is force Newton per meter. The force per unit length or surface energy per unit area, you can say. Surface energy per unit area. Acting in the plane of interface between the liquid and bounding surface. Remember, please. Now let us move on the next question. Okay. So next question is for an incompressible fluid, does density vary with temperature and pressure? For incompressible fluids, does density vary with temperature and pressure? So this question we have, I think, solved already. So it varies for all temperature for incompressible. So this question I think we have already solved. Previously it was the first question. So remain constant because it is your incompressible, not the compressible one. So this question also we have solved, I think. Question number 10. The depth of the center of pressure for a rectangular lamina, yes, we have already solved. The height h and the width b immersed the vertically in the water with the longest edge and the vertical and top is touching the water surface. So the answer was this 2h by 3. How it is calculated, you know already. Question 11. A hydrometer is used to determine zero relative humidity, surface tension of liquid, specific gravity of the liquid, and the viscosity of the liquid. The zero or a hydrometer is used to determine which option will be the correct. A hydrometer used to determine zero relative humidity, surface tension of liquid, specific gravity of liquids, and the viscosity of the liquids. The hydrometer is used for the specific gravity of the liquid. Remember, please. Option C will be the correct. Next one. A hydrometer is an instrument used to measure specific gravity or relative density of liquid, that is, the ratio of density of liquid to the density of water. Next question. The kinematic viscosity is expressed in. So you know already the kinematic viscosity is nothing but it is your dynamic viscosity divided by rho. Sometime you have been confused whether it is rho by dynamic viscosity or dynamic viscosity is by density. So remember please, if you are calculating the viscosity here, so in the nominator, the viscosity term should be there, not in the denominator. Just for your understanding, I'm telling. This is not a key concept or any scientific. So just try to understand. Just for your remember. Okay. What I am telling this is not a logic, but for your remember, these have the scientific reason, but just as a logic you can use. If you are calculating the viscosity, so in the nominator viscosity term should be there. So you will always remember. So we have already calculated the dynamic viscosity, this unit, Newton second per meter square, and this is your meter square, and rho is meter cube per second. So what is Newton? Newton is nothing but kg meter square per second, meter per second square. That is mass into acceleration. So I'll write here kg mass. Oh, rho is nothing but rho is not meter cube per second. Rho is kg divided by meter cube. So kg meter per second square, second meter square, kg meter cube. So this meter square, this meter cancel out, 1 second, second cancel out, and this kg will be the cancel out. Meter and this meter will form meter square. Combinedly, you can write as second, meter square per second. Option B will be the correct for this. So how it is correct, you know already. I have told you. So finally, hope you understand. So your dynamic viscosity is mu del u by del y. So now let us solve the next set of the question 2024. The similar question here. A fluid occupied 24 meter cube. Calculate the specific volume. Specific volume in meter cube per kg if the fluid mass is 16. 24 specific volume. So 1.5. The option D will be the correct. Next question. The cavitation is caused by high velocity, low pressure, high temperature. The cavitation. The cavitation is caused by high viscosity, low pressure, high temperature. Remember, please, the cavitation is phenomena due to the low pressure. Detailed solution. The cavitation is defined as the process of formation of vapor phase in a liquid when it is subjected to reduced pressure at constant ambient temperature. Cavitation is defined as the process of formation of vapor phase of liquid when it is subjected to reduce pressure at constant ambient temperature. So remember. Next question, question number 3. The shear stress in the Newtonian fluid is proportional to pressure, strain rate, the inverse of viscosity. Shear stress in the Newtonian fluid is proportional to shear stress in the Newtonian fluid is proportional to pressure, strain rate, the inverse of viscosity. So it is proportional to strain rate, not strain. You know the formula del u by del y. So it is proportional to del u by del y. This is your strain rate. Okay. So del u by del y is your strain rate. Next question. Which of the following is an example of phenomena of surface tension? Raindrop, rise of sap in a tree, breakup of liquid jet, all of the above. We have already solved. So question number 4. For question number 4, option D will be the correct. Next question, question number 5. The liquid head of mercury, the liquid head of mercury corresponding to 8 kilopascal is, take a specific gravity of the mercury is 13.6. So this is also we have already solved. So what is 8? 8 kilopascal is equal to rho g h. So here you need to calculate the h. So 8,000 for I am writing in the Pascal, and this is your density of mercury is 13.6 already in the given. The specific gravity need to multiply with the 1,000, then you will convert the specific gravity in terms of your density of mercury. G is 10. So 3030 will be cancelled out. So 8 divided by 136. So it is coming around 3. And here you need to not 3. So not 3. Okay, so this will give you the answer in meter. So you need to for centimeter just multiply with the 300. So now it is 6. Yes, the 6 will be the correct. So okay, the similar procedure here. Now let us move on the next one. Which is a phenomena by which a liquid rise into a thin glass tube above or below its general level. So, what will be the correct one? Surface tension, capillarity, cohesion, adhesion. Which phenomena by which the liquid rise into the thin glass tube above or below its general level? It is your capillarity. Remember, please. Capillarity rise or capillarity is a phenomena in which liquid spontaneously rise or fall in a narrow space, such as thin tube or the void of the porous material. Very important. Next question. The unit of specific gravity. Which one of the following is the dimension of a specific gravity? You know, specific gravity is what? The density by density. So the unit will be cancelled out. So option A will be the correct for question number 7. This is the dimensionless parameter. The specific gravity is the ratio of the specific weight of fluid to the specific weight of the standard fluid. Being a ratio of two quantities with the same unit, the specific gravity has no unit. Now let us move on the next one. Question number 8. Surface tension is due to cohesion and adhesion, adhesion only, none of the above. The surface tension is due to cohesion only, adhesion only, none of the above. The surface tension is due to the cohesion, adhesion, none of the above. It is the cohesion only, not adhesion. The surface tension is a cohesive force which develop between two immiscible fluid and develop a tension on the surface. Means the water in the container water is having. So if this is water is here, so here outside air and this is your water. So this is 1 and 2. So here you can say two immiscible fluids. Fluid means it may be the air and water develop a tension on the surface. So here the surface over the surface tension is developed. Remember. Next question number 9. Okay. For an incompressible fluid, does density vary with temperature and pressure? For incompressible, okay. The similar question we have seen already. So it varies for all temperature and pressure range. It remain constant. It varies only for lower values of the temperature or is wrong, you know already. The option B is correct for this question. For incompressible fluid, the change in density is negligible. Thus, it does not change with temperature and the pressure. Next question. Which one of the following pressure unit represent the least pressure? Whether it is millibar, mm of Hg, Newton per, not this here, double slash, Newton per mm square, kgf by centimeter square. Which representing the least unit, minimum unit you can say, which is your millibar. Option A is correct for question number 10. So here explanation is given. So detailed solution is given. Let us assume one ATM, one atmospheric pressure. So one atmospheric pressure is nothing but 10.1 mm of meter of water, one atmospheric pressure. 760 of Hg, 1013 millibar. One atmosphere, if you want to write in the kilopascal, you will write 101.3. If you want to write the one atmospheric pressure in terms of kgf, so 1.013. If you want to write in the Newton per mm square, you can write like 0.1013 Newton per mm square. So which is the minimum? Your here millibar is your minimum. The minimum means here means for writing one atmosphere, you have to write more times or more. If you will see here, the focus on the number for your just for the focus on the number, the more number having millibar. For example, if you have 1 rupees, so you have to convert in the 25, 50, 0.25, I am telling 0.5. So for 0.5, you have four coins. For 0.25, for 0.5, you have two coins. So least one is for 1 rupees. This. So similarly, for writing the one atmosphere, you have to have 1013. But other one, 101 only, 1.013. This is another zero point 0.1. For Hg is 0.70760 mm, and for H2O 10.1. So this is your very maximum. The number is very maximum. That's why the least one is your millibar. Option A. So hopefully you understand. Next question. A similar question. I think we have already solved. A hydrometer is used to determine zero relative humidity, surface tension of liquid, specific gravity of the liquid, viscosity of the liquid. So hydrometer is used to determine zero relative humidity, surface tension, specific gravity of the liquid, viscosity of the liquid. We have already solved the questions for question number 11. Option C is correct. So, okay, so just let me on the battery of the laptop. Okay. So here you can see the option C is correct for question number 11. A hydrometer is an instrument detailed solution used to measure specific gravity or relative density of liquids. That is the ratio of density of the liquid to the density of water. Sometimes you might be confused with the fluid. Specific gravity of fluid, someone right. So if the fluid is a combination of, combinedly say, the air and liquid. So you can measure the gravity of the fluid using the hydrometer. Maybe the question framed like that also for confusing the specific gravity of the fluid and none of the above. So which one option you will correct? For here, let us assume here was the specific gravity. This, let me just design in another way this question of fluid, and the option D was none of the above. So which you will prefer? Whether first, second is not the correct, whether you will go with the C and do most appropriate will be the D, because the fluid having air also you cannot calculate with hydrometer. Okay, next question, the last question for today. The unit of dynamic viscosity. Very simple. So tau is equal to mu du by dy. So in terms of Newton, you have to write force by area and here your du by dy. So Newton meter square mu meter per second meter. So this meter will be the cancel out. So dynamic viscosity is Newton second per meter square. So this will be the your correct. So which option is correct? Newton second per meter square. Option B is correct here. This is unit of your meter square per second for kinematic viscosity. This is your dynamic viscosity. Pascal second per meter square. Is it possible? Maybe in the multiple choice question you may face the problems. So this will give you the Pascal, mu meter per second meter. So mu will be your Pascal second, not Pascal second per meter square. Whether this will be the correct, let me just check. This is your Newton. So Newton is your meter, kg per meter, kg into meter per second square. Second square. Meter square is equal to mu meter second meter. Second will be the cancel out. Meter will be the cancel out. So kg divided by meter second. So this will be the correct again. So this both are not correct. This is not correct. So option B is correct only. Okay, so only option B is correct. So hope you understand the things and you will enjoy a lot. So we have solved a lot of question around, I think 10 question here. How much? Let me just 10 question and then a 12 question here and also here the 12 question. Okay. So in the first set was 10, then again 12, then again 12. So this is 24 and 10 is 34 question we have solved within 2 hours in detail. So hopefully you understand the things If anyone have any doubt, you can mail me. Again, I'll write here my mail ID. So you can mail om1996 at the rate IITZ. Remember, please, dot AC dot in. All things in small letter. So you can mail me question if you have any doubt. Okay, hopefully you all understand. So thank you for today's session.